Okay, so in question 11, we are given a diagram of a parabola, a quadratic graph, and it's an upside down one, so it's a negative x squared, or in this case it's t squared, because we're told that the equation of the graph is h of t is minus 2t times t minus 14. Okay, and this represents the height of a rocket against the time that the rocket is taken in its flight. So obviously the rocket is starting here at 0, it flies up, hits the point where it is at its maximum height, and then it obviously starts to descend, and when it gets back to this point here, that is when the rocket hits the ground or whatever, and that gives us the duration of the rocket's flight. So part A is asking us how many seconds is the rocket in flight. So that is basically asking you the same as what's that distance there. Okay, so we know that it starts at 0. Okay, so we need to work out that other coordinate. Now it crosses the x-axis, or in this case the t-axis. Okay, when y, or in this case h, is 0. You're basically trying to find when does the rocket have 0 height again. Okay, so we're setting the height equal to 0, and we've got this equation, and that's just something that you have to solve, and it's already factorised for you. So you've got minus 2t equals 0, and you've got t minus 14 equals 0, and it should be obvious from there what the answer is going to be and how long the rocket is in flight. Okay, then part B, what is the maximum height reached by the rocket? Well, we can see that from the graph. The maximum height reached by the rocket is at that point there. Okay, so we need two things. First of all, we are going to need when that height occurs. So after how many seconds? Now we know about the symmetry of these quadratic graphs, so it'd be suggesting that you're going to need to work out what that value of t is halfway between 0 and whatever you've worked out for this one here. Once you have that value, you're trying to find the corresponding height. Now the function states that the height at any given time t is minus 2 times t minus 14. So once you have that value for t, you're just substituting it into the formula and it will give you the maximum height. It's the same as the y coordinate effectively, because every coordinate you've got along this, okay, the t is the time and the h will give you the height. So for instance, if I put in when t is 1, so after 1 second, okay, the height is going to be minus 2 times 1 times 1 minus 14. So that's minus 2 times minus 13. So the height would be 26 meters, okay, because the coordinate of that point is 126. So every coordinate gives you the time taken and the height of the rocket at that time. So hopefully that helps, but if not, let me know.